All right. So for Raspberry Pi, actually the bootloader, like I've said, it uses the Broadcom bootloader. This figure shows us the booting sequence for Raspberry Pi. Okay. So you can see it goes through a step by step. Eventually, it's uh, just, I mean, it's the same as this. Eventually, it will load the operating system and pass the control to the operating system. And the operating system for Raspberry Pi is the Linux, is the embedded version of Linux. Okay, so the Linux kernel actually is the last step to load into the memory. And once the Linux kernel is loaded into the memory, then then everything will be controlled by the operating system. So you can see when we turn on the power of Raspberry Pi, it goes through several steps. So first, it has to execute the program saved in the BIOS to initialize all the hardware components, and then it will go to pass the control to the bootloader, and then the bootloader will do this several steps. So eventually, the operating system will be loaded into the memory, and once the operating system is loaded in the memory, then the operating system will take the control, and that will, the operating system will start to control the whole system to manage all the service, all the program executing, all the tasks. Okay, so as a user at this time, you can communicate with the computer system through the help of the operating system. Okay, so so that's the procedure that each time when you plug the power into the Raspberry Pi power slot, and then it spends some time. It takes some time, like maybe half minute or 1 minute, to uh, let the system start up. So the system start up. Um, uh, the booting procedure actually goes through these several steps. Okay, and in fact, you can see here it prepares and allocate the system memory for the operating system. Okay, so the main memory on uh, on a Linux system, we know Raspberry Pi is a Linux system, right? So it has two spaces. It has a kernel space and a user space. Okay, so the main memory actually has two parts. Not physically two parts. Actually, it's divided by the operating system. Okay, so operating system will separate uh, the will divide the main memory into two parts. One part, the operating system use it to save all those kernel applications. Okay, and the other part, the operating system designates as user space. And so, and from the names, we know that they have different purposes. So for kernel space, it means that's the memory space, you know, designated for Linux kernels. And we know Linux kernels actually they are the operating system files, operating system programs. Okay, so they are system programs. Usually for system programs, the user cannot access, because if a user can freely access a system program, that will create a big problem, because if a user modify the system programs, actually that will crash the system. Okay, and on the other hand, for user space, from the name, we already know that it's designated for users. Okay, so that means as a user, for example, we all users. When you turn on the power of Raspberry Pi, the power goes through all those booting procedures, and eventually um, the operating system will control the whole system, and the operating system actually designates a part of the memory for user space. That means, as a user, our programs, our data, they all saved in that area. Okay, so that's and for kernel space, for the kernel, the Linux kernel actually runs in an area of system memory called the kernel space. So the kernel space is designated for the system applications, and the regular user applications run in an area of system memory called user space. So user space, kernel space, just from the name, we can find that the characteristics or the functionality, the differences. Okay, so the Linux kernel actually owns and has full access to all of the physical memory and resources on the Raspberry Pi, because we know Linux kernel is the operating system programs. Okay, so that's definitely it controls the whole system. Definitely it can access anywhere. And a kernel module is an object file that contains binary code which can be loaded and unloaded from the kernel on demand. Okay, so that's basically kernel. Just means all those the system applications, system programs. Okay, definitely system programs, they have high authorities to control the whole Raspberry Pi system. Okay. And this figure actually give us a picture that how does the user space and kernel space looks like. Okay, so the Linux user space and kernel space architectures are shown in this figure. So you can see actually the bottom block, that's the physical hardware. Okay, and then the system, Linux system, which actually we use kernel space to save or to all the Linux system kernel programs are saved in the kernel space. Okay, so logically, the kernel space is just on top of the hardware. Okay, and then on top of the kernel space, we have this user space. So we know user space is the memory area to save general user applications. Okay, so from this picture, you can see that as a user, when we have a program, when we try to run the program, okay, for example, you want to, there are some LEDs on the Raspberry Pi board, okay, which is in the physical hardware area. Okay, so as a user, when you write a program, your program say turn on that specific LED or turn off that specific LED. In fact, your program doesn't directly control the LED. Your program has to go through the kernel, the Linux kernel. Okay, so the Linux kernel actually works as an interface. So you have to let the kernel know that you want to turn on that specific LED or you want to turn off that specific LED, and then kernel will communicate with the hardware to make that happen. Okay, so that's the normal procedure that whenever you want to do something with the hardware. Okay, in fact, that's also reasonable and also is safe, because as a user, if without the interface of the operating system, that actually provides a security problem. Okay, so everything actually is controlled by the operating system. A user just has the capability to do certain things, Okay, so that's this actually give us a very clear picture about the Linux user space and kernel space architectures. Okay. All right, and in fact, the computer I mean the Raspberry Pi computer actually um, provide the system service to user application, right? Like we saw this picture. From this picture, we know that the kernel actually provides service to the user space or programs. Okay, so user programs, like I've said, it cannot directly communicate with the physical hardware. Actually, it has to be it has to go through the kernel space. So the kernel space basically works as a service system to serve the user space. So the service program actually in Raspberry Pi is called this system D systems manager. Okay, it's a service manager. Okay. And this kind of service manager starts and stops services, and it provides certain services like web servers or SSH server. In fact, there are several kind of when you try to you can connect to Raspberry Pi by using SSH. Okay? SSH actually is a secured login protocol. Okay, so all those services actually provided by this system D. In fact, you don't specifically, when you go to Raspberry Pi, you don't specifically run this system D. But whenever you do something, the system D will automatically provide the service that you request. Okay, so the system D system and service manager is a recent and somewhat controversial addition to Linux that aims to replace and remain backward compatible with those previous systems. Okay, and system D consists of a software bundle for login management, journal logging, device management, time synchronization, and more. So basically, system D is a service manager, is a system and service manager. Okay, so it manages a lot of service protocols, like if there's somebody try to log into the Raspberry Pi by using SSH, for example, or if you want your Raspberry Pi work as a web server, then the system D will provide that service to make sure that your Raspberry Pi is working correctly as a web server. Okay, Raspberry Pi actually is very powerful. You can make your Raspberry Pi as a web server. For example, you can use your Raspberry Pi work as a web server, and then you can connect your Raspberry Pi to your, for example, garage door. Okay, and then you can use an app to connect to the Raspberry Pi, because if you make your Raspberry Pi as a web server, then you can use your phone to control the garage door or your light. Okay, so you can make your home a smart home or smart house, by doing that. Okay, so that's very interesting because Raspberry Pi actually provides a lot of possibilities to for hobbyists to do all kinds of applications or all kinds of projects. Okay, and in fact, to manage Linux system, there is a super user account. Okay, so in fact, the Raspberry Pi account is a super user. So the super as a super user, whenever you want to do something, you will have to use the sudo, the sudo. Okay, so that's so on Linux systems, the system administrator account has the highest level of security access to all commands and files. Okay, so that's true for all kinds of Linux system. Okay. And this account is referred to as the root account or super user. And when performing general operations on a Linux system, that you try to avoid being logged in as the super user, because if you log in as a super user, that means you have a higher authority. And sometimes you may some kind of a command may change the system. Okay? If you log in as a super user, you may mistakenly modify certain system configuration, okay? And that may destroy your system. Okay, so most of the time, actually, you don't want to log in to the system as a super user, because if you log in as a non-super user, a normal user, then it's impossible for you to damage the system. Okay, so that's something that you want to keep in mind. Okay, a special tool called sudo, sudo, is used whenever you want to perform system administration commands. Okay, in fact, let me see. I can show you a Linux system. All right, so you can see this is a Linux system. In this Linux system, this is not the Raspberry Pi Linux system, but they are pretty similar, because this is a Linux system. Raspberry Pi is an embedded version of Linux system, and they, from a user point of view, actually they are the same. Okay, because the only difference is the kernel. Well, for this server based Linux, actually the kernel provides service for the server, and for Raspberry Pi, the kernel provides the service for the embedded system. Okay, but for user, we don't see from the point the point of view of a user, we don't see much difference. Okay, so for Linux system, actually, remember, we have a pseudo, we have a super user. So if you log in as a super user, you can use this sudo. So you can see sudo actually can do all these things. Okay, it's a very powerful command or scheme that you want to avoid only when it's necessary. For example, sometimes you need to install a must-have software. For example, if you want to install the Python to the whole system, then you may want to use sudo. And in fact, in Linux system, for Python, it's better to use virtual environment. Okay, so that's for example, you can use Conda, Anaconda. So if you search for Anaconda, actually that's very popular for using Python in virtual environment. Okay, so by using virtual environment, actually you don't change anything on the system level, kernel programs, actually you only work in your own user account. Okay, so for Linux, actually each user, you have a user account. Like for example, my username in this Linux system is YOWANG. That's my username. Okay? If I go out, you can see in this computer, in this Linux computer, there are this many users. Okay, so each user, they have their specific username, and each user, they maintain their own password. Okay, so if I go to another user's account, for example, I go into this user's account, you can see I can read their file. I can read their file, but I cannot execute their file. Okay. Let's see. If I go back to my own account, you can see the first, I can list all the files and folder directory in this in my account, and you can see the username is here. That means I have you know, all these files and directories, they belong to me. Okay, and when I list the other users you know, files and folders, you can see their owner for the directory is you know, the other user. Okay, so each user, they maintain their own files and folders, and they have the you know, the authority to their own file. So for example, this one, I can see their file, but I cannot execute because it's not belong to me. Okay, and the mode for the files and directories actually shows here. Okay, so you can see RWX. R means read, W means write, X means execute. Okay, so this means I can read, write, and execute. Okay, and so you can see this give us all the you know, permission what you can do to the file. Okay, so same thing if you go if you use Raspberry Pi, you will see the same. Okay, so they're exactly the same. Okay, all right. Okay, so so the Linux file system is a hierarchy of directories used to organize files as a Linux system. So we just see we just saw the Linux file system is I use ls ll to list all the files. Remember, and Linux uses data structures called inodes to represent file system objects such as files and directories. Okay, and when a Linux extended file system is created on a physical disk, okay, so a table, you know, the files for Linux system, actually for Windows system, is the same. Okay, all the files, they are organized in a hierarchical structure. Okay, files are saved in directory, and then, you know, there are other directories in directories, in directory files, in directory. So it's a hierarchical structure, and this structure actually has to be maintained somewhere, because if you don't have, if you don't maintain this file structure, then in the future, if you want to find the file, it's impossible, right? So that's why there must be a file table maintained, created, and saved in the on the physical disk. Okay, so for Raspberry Pi is the SD card. You see, everything is saved in the SD card. Okay, so the file are saved in the SD card, and also a table to tell the system where is the file is also saved in the SD card. Okay, so that's the file system. So for a file system, basically, you have you have a table. The table maintains where is the file, what is the name of the file. It's a lookup table. So whenever the kernel try to locate a file, it will go to that table first to find where is that file, and then the kernel can go to that location, get the file, either write the file or read the file. Okay, so that's the Linux file system. Okay. And if we go back to the Linux window I have before, so you can see for the file structure, if I go to the root directory, so you can see this is the root directory for Linux system. So you can see in a Linux system what kind of file directories you may have. You definitely you will have a USR, that means it's for user. Okay, and you will have a home directory to hold all those user directories, and you have a lib directory to hold all those libraries for your system, and you have bin directory to hold all those binary files. Binary files in Linux system means all those executable application files. Okay, and so for our user account, actually it's in the home directory. Okay, so in the home directory, you can see all of the users are in the home directory. And if you go to my home directory, you will see my files, my directories, everything. Okay, and if you go to, for example, user local directory, you can see there are some local installed applications like CUDA. CUDA is it's a software for NVIDIA GPU. Okay, and you can go to bin, for example. You see that there are, and you see star here. That indicates they are all executable programs. Okay, if I list them, you will see, for all of them, they have an X here. That means I can execute, or everyone can execute them. Okay, so that's that's something that is related to the Linux file system. Okay. So you can see when I list the files or directories, remember we have this DRWX, RWX, RWX, 3WX, right? The first three, that's the permission for the user, for yourself, okay? And the second, that's for the group, because actually, for example, in a university, let's use a university as an example. The faculty members in, for example, College of Engineering, we can make them as a group. Okay, so each user belongs to a specific group, and so that's why for group users, they have this permission, and this for others, doesn't belong to your group. It's not the same user. So for those people, they can do this. Okay. If I go back to this, actually, you can see, these files are actually, these directories and files, they are in my user account. Okay, so that means I can do anything. I can read, I can write, I can execute. Okay, but for other people, for the group, the users in my same group, they can do this. For other people, they can only read and execute. They cannot write. They cannot change it. Okay, and for example, for this account, they have only one folder directory, and for their directory, I am not in the same group as this user. Okay, so that means I can only read and execute. I cannot write. Okay, so that's the permission of a file and directory. Okay, so it's in fact this is very similar to Windows. Okay, Windows has the almost the same you know um, structure or architecture. Okay, and so usually we can use a change mode, chmod, to change this. Okay, so you have 4, 2, 1. So that means if you want to change this value to 1, you have to use a 4. If you want to change this value to 1, you have to use 2. If you want to change this value to 1, you have to use 1. And if you want to change all of these 3 to 1s, you have to add this together to make it 7. Okay. So for example, if you want to change the other for others, and for you want to disable the read write X for group and others, then you use 7000. Okay, 7 is for yourself, and 0, the second 0 is for group, and the last 0 is for others. Okay, so that's and if you want to make sure that nobody can execute, but everyone can write and read and write, then you use 666, because for this value is 4, this value is 2. Basically, it's just a binary. Okay, so if you have 3-bit binary, we know this bit means 1, this bit means 2, and this bit means 4, right? So that's so that this, by doing this, actually you can change the mode of the specific directory or file. Let me show you. Okay, so for example, in my account, all right. So for example, this temp directory. Okay, so I can change the mode for the temp directory. It's already I have 111, that's 7, 111 is 7, but I have a 101, that's 5. Okay, so I want to change it to a 7. So I can do what I can do. I can use a change mode 777 temp. Okay, so once I do that, you see temp becomes RWX, RWX, RWX. Okay, it's different from the previous permission is RWX, RWX, or 0x. So if I want to change back, I can use change mode 775. Okay, temp, and then you can see temp actually the mode, the permission was changed back. Okay, so that's that's something that you can use to change the permission for a specific file or specific directory. Okay, and to link file and directories in Linux, you can use 2 kinds of link, soft link and hard link. In fact, no matter soft link and hard link, you use ln command. Okay, so you use ln. This ln is a command to link a file. Okay. Link file means you link a file to another file. Okay. So this is also very important in computer in Linux system. So I can show you. You can see, CUDA is linked here. And when you see an arrow, that means this is a linked file. Okay, so this file actually is linked to this directory, which means you can go into CUDA. No, this is not a directory. Actually, okay. So you can go into CUDA. Once you into CUDA, actually, you in reality, actually, you are in this directory. Okay, so that's something that very useful in Linux system. Okay, and here we have some Linux commands, and you want to be familiar with if you try to use a Linux system, because Raspberry Pi actually is a Linux system, so it's better to get familiar with the Linux commands. Okay, so there are a lot of Linux commands. These are several examples. Filter commands, sort command. So you can use this Linux commands to do all kinds of operations. Okay. So there are some other Linux commands. For example, then we can show you. I can show you one example. If I use echo. This echo means it's very similar as a print operation or display operation. So it's path. This path actually is a system path. So showing the system path, because for example in Windows, you already know that in Windows actually you also have a path parameter. This path parameter actually give you the system path. That means whenever you execute a program, that the operating system will first go to those system paths to search for this program. Okay, so the same thing for Linux. This path actually is a system path. So if you want to know what paths are in this system path parameter, you can use echo. Echo is to display the path, all the paths. Okay, so so you can see we have so many very useful Linux commands. Here we have cat, diff, tar, all kinds of commands. This is not a complete list. It's just part of the Linux commands list. Okay. And so for Linux processes, a process is an instance of a program that is running on the operating system. Okay, and you have to use PS. PS is a command in Linux. Okay, so in Linux, you type in PS, you can list all the currently executing process. Okay, so and you know that Linux actually is a multitasking operating system that enables you to run processes in the background while using a program that is running in the foreground. So you can make your process into background. Okay, by typing a $. Actually, you put your process into a background. Okay, my throat is it's not that